maybe just for recording purposes, let me just start over again. Sorry for those who have to go through this again. So title of the talk, why you should consider adding a Makefile into your Python project. The asterisks here represent that it doesn't really have to be a Python project. It can be just about any type of project. You can just cater Makefiles to support your project. And the objectives for this talk, I'm going to give you a short introduction to Makefiles. Who needs Makefiles? If you use shell scripts, I mean, I've personally been using shell scripts for like forever, but Makefiles are, yeah. Anyways, the other thing would be how Makefiles are structured and why you should bother using Makefiles. And a slight demo towards the end, and also I've added some resources for you to check out. So at the end of this talk, we're gonna compile this video and presentation, and then we're just gonna send it out. So a short intro on Makefiles. So according to Wikipedia, Makefile is a file which contains a set of directives used by a make. Make is a GNU package, which is used to build automation tool to generate targets. This was first introduced 44 years ago. Yeah, I know. And till these days, you can still find it in most programming projects. I'm going to show you now. It's widely used in Unix and Unix-like operating systems for automation. Generally, it's used to build executable programs and libraries from source. As I mentioned earlier, most people that use Makefiles, they use it in C and C++ projects. Besides building those projects, you can also use it to manage projects where some files can be updated automatically when you change a file. Say, for instance, for an example, the way I usually make files in my day-to-day at CAM, I would be connecting to we call them dev boxes, but it's a node that is situated in CAM lab at the office. So I would be tinkering with the code on my local box, and then my Makefile would resync that code to the dev box or at the office, and then I can just run my test from the dev box. So that's another example of how I use Makefiles. So every time when I make a change on the work on my local, it would just resync automatically in the background to my dev box. That one example. Like I highlighted, Makefiles are not really limited to compiling C and C++ programs. We'll just continue. Give you a brief. What do you call this? Sorry, I mumbled time to time, so it should be fine. We'll edit it on the recording. So don't worry about it. Just a disclaimer: I'm not an expert. Most of this stuff is just tinkering and me playing around and breaking stuff. Those who know me or those who have worked with me know that I like breaking things and moving fast, as Mark Zuckerberg likes to say it. So yeah, continuing on, who needs Makefiles if I use shell scripts already? So functionality, it's one of the important things when it comes to Makefiles. Makefiles offer superior functionality than bash scripts. You can argue. And scripts are usually a sequence of instructions, as we know, which are procedural paradigm, and Makefiles pretty much just lets us specify prerequisites and implications. And in software language, we call this declarative paradigm. So you can just declare the rules and then call them as you wish. However, with scripts, you would just probably need arguments for building the stuff and so on and so forth. And with a Makefile, you can simply specify rules for compilation, as I just said now, to deal with useful procedures for the code maintenance, for example, or decide when and if we need to rebuild a file or executable. As I did mention, the type of things that I do with Makefiles related to CAM. The other thing is minimum rebuilds as possible in minimum rebuilds are possible in Makefile, whereas the base script requires a lot of time and effort to achieve the same functionality. I've had that experience in the past. And sadly, it's a very old tool, like I said, 44 years old now, and the syntax can be a little daunting. But yeah, if you get it right, it's gonna work 100%. So you might be wondering what are these makefiles and how they're structured. So if you've never seen one, this is a typical structure that a makefile follows. So you've got your target and dependencies and system commands. And a target is just a name of an action that that makefile should carry out. For instance, I've got this example here. You would just need run make virtual env. So instead of the usual thing that Pythonistas usually do when they're creating a virtual environment, they will just type it down, virtual environment, blah, 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 blah. And obviously that is error prone and so on and so forth. But Makefile just makes our life a lot more easier. So like I was saying, you would just define a target, and a typical Makefile, you would just type it, the file, you would just type it as shown here. And Makefiles also have a prerequisite of dependencies, which will be an action that needs to be run before the current target can be run. Typically, I usually have a clean dependencies. So I want to clean all the directories or all the files that are on that current directory before I create a virtual environment. And like I said, there are system commands. These are also called recipes, which is an action that that the make carries out. It can be more than one command, and the one thing people always forget is that it consists of a single tab. Mostly you would find your IDEs or your text editors. You have configured it such that it uses spaces instead of tabs. I've run into those type of issues before, so that's one thing that you must also always consider. Always use tabs. So as I was highlighting, usually what a typical Python developer would do when they're creating a virtual environment, it's execute this piece of code here. And in most cases, people run into typos, misplaced arguments, and so on and so forth. So having it structured into a makefile just removes that the middleman and fixes up stuff. So instead of typing the whole thing, you just type all these 9 characters. So make space VN. So like I said, makefiles, the way they are structured. So this is just a typical example I took from the internet. This is mainly for compiling a C or C++ Hello World program. This program consists of 3 files. Obviously, there are no files in this, but yeah. Anyways, so this would be a structure of how a makefile would look like. And as I did mention in the previous slide, the syntax can be daunting at first, but once you get used to it, it's going to be easier to understand. Mostly it follows shell type of defining variables and so on and so forth. But now, why should you bother using makefiles for a project? If you're like me, you're probably tired of typing in long commands. I know I am. I usually have aliases, a list of aliases for all the commands that I usually type on a daily basis, and or the other reason would be to save all those commands in your README file, in your project root. I've seen a lot of people doing that, so that's the other thing that also bothers me. One other thing, like I mentioned, is to manually type commands. So imagine if you need to type in this command on your screen. This is a typical Docker when you're running a script inside a Docker container while mounting a volume and sharing sound, and sharing your video, having port forwarding as well. So you can just imagine if you have to type this every single day, that will be a painful exercise. And this is there's a lot of errors involved, or well, problems with this approach. One can easily make a mistake, like I said, a typo. You can easily make a typo, and debugging that typo is going to be a pain. Um, this is very time consuming, considering that if you have this saved in the README file, you need to open that README file, copy, open terminal, run. Over time, it's gonna become boring, and yeah, it's a bit cumbersome. The other thing, it definitely affects your efficiency. I mean, there's a couple of there's a couple of issues. The list just goes on. But what if this process could be simplified? It's just run in a container, and then you've already, if in that case, you've defined a target running the container, which runs this code, and then boom, you're done. That's how easy it would be. But like Linus always says, talk is cheap. Show me the code. So I'm gonna give you a rundown, not really much of a rundown, but it's gonna be a brief rundown on this over-engineered Makefile that I use for my project, my personal project. It's very over-engineered and bloated, but I guess that's how you learn, by tinkering and messing things out. So maybe just a simple rundown. So, like I said, you would define, in this case, I'm defining a function. This is how we would define a typical function. Defining a print help. I'm going to give you a simple demo just now. In here, you can either, it would be nice, you can either export your own Python environment. In this case, since I dab a lot on Python, so most of my work is Python related. If you work with other programming languages, you would define your environment here, and there's a typical function for installing packages if they don't exist. So you would iterate over a list of packages that you've given. There's a function, and if that package is not installed, you would just pip install it. That makes a lot of yeah. I mean, you're just gonna show you in the demo, but it makes life a lot more easier than having to type pip install every time. Pip install yada. You just run make install this package, and some Docker related stuff. This just install Docker if you don't have it. What else? Oh, this is the one I was talking about. Create virtual env. You can see that in line 101, create virtual env. We'll call that function and pass it virtual env. This will just install virtual env if it doesn't exist. And if the package name, say for instance, your directory is called temp, this will be dot temp underscore venv. So this will create a dot temp underscore venv directory, which will create a virtual environment for whichever Python version you've added, and upgrade pip in the background, and you are good to go. So this is just a brief. If you're really interested, you can check it out. This generic Makefile, you can play around with it. And let me just move my terminal. I have a directory open here. I don't know if you guys can see it. So a typical Makefile, this is how I usually use this Makefile on my side projects. So here, read Makefile. This is what typical people you do, or typical, I mean myself. You would have this piece of code somewhere in your README file, and you copy and paste. That for me feels a bit inefficient, but yeah, go for it. So that just downloads Makefile. So you can that's the Makefile that I just walked you through. And if I just type make, it gives me this nice help. This is just a template. So if when I work on different projects, I'll just edit this and fix it for that to suit that project. So, for instance, you can see that you can easily build Docker images and easily run those Docker. Yeah, you can just run that Docker image in the container. So instead of typing Docker run blah blah blah, Docker run yada 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 yada, you can just make run in the container that should run whatever Makefile that you have. I mean, whatever container that you have. So, like I said, this is over-engineered, bloated, and simple thing that I usually do when I'm tinkering. I would create. Yeah, it's highly advisable to create a virtual environment. So what I would do, just create virtual environment. That will create my virtual environment. Upgrade pip. So you see that it has created my virtual environment, and yeah, it has created pip. I would need to source that virtual environment to see. Now this is, yeah, so that's what we have. So in that virtual environment, I've installed and everything is there. From here onwards, you will just start tinkering and playing around. The other cool thing that I like about this, it would be creating creating a repository with boilerplate code, and then pushing it up to GitHub. So this would let me just go up here. So this target git edit repo just creates a new git repository and adds boiler code in it. In the boiler code, it will just execute this target, which simply adds a readme file and git ignore. So if you can just check here, I only have this files and directory. So what I would typically do every time would be just git init repo, and it created a repository. Can't type when people are watching. So created a new repository, and if I check the log, there's an added readme file and git ignore, and we check the file content. Those are the files. So it downloaded git ignore. For those who don't know git ignore, Google will be a good start. And created my readme file based on the name of the directory. And when I'm done with that, mostly what I usually do is create repo and push. So this is just an alias that forms part of my git config. So this is what would typically happen. So I've just created a new repository with all those stuff. Just open this. When you open this, you have that readme file that you can git ignore. It was pushed a minute ago. So just by running two commands, I'm able to push my stuff. So that was the git create repo, and the other one was just this. So just those two, I can be able to create a repo, and all this is made possible using Makefiles. I could have added this bit of code into my main file, but I figured for the purpose of this demo, it's not really worth it. But yeah, I think that pretty much concludes the talk, I guess. But yeah, and like I mentioned, some of the resources that I found very useful would definitely be the GNU Make PDF. I think it's about 130 pages, but it's worth reading. There's an introduction to Make, blog, and generic Makefile, the one that I just showed you now, and some of YouTube search queries that you can check out, and some blogs that people have written. So I think that concludes my talk, and thank you for spending this half an hour on this talk. If you have any questions, let me check on the chat if there's any questions. There is none. So James says, why don't you have the Makefile source the venenv as well? I've tried sourcing the venenv as well, but it sources it on a different shell. So I've tried tinkering and getting it to work, but in the end, it did. So part of the stuff that I was reading would be to use one shell. I've tried that; it didn't work. But yeah, I guess something that one can look into. And Anele said, what would be significant difference of having a Makefile over native bash aliases? Native bash aliases, they only reside on your own local system, unless you have them somewhere in the Git repo and you want to always pull that Git repo whenever you're working elsewhere. You can do that, but I wouldn't really advise that. Instead, you can just define whatever is in your bash aliases in your Makefile and then generate it from there. So yeah, I think that concludes the talk. Thank you for being here, and looking forward to receiving a lot of your talks in the future, so that we can have this tech talk continuing on. So as Tofik suggested, if you are okay, you can share your video and we can just do a meet and greet, since we haven't seen a lot of us in a very long time. But yeah, thank you for spending your time with me.